Today I'm going to introduce the idea of a hypothesis test. And all this is, I know it's a new word for you, it's just simply a test where we want to see if something that we previously thought was true remains true if we do an experiment. So the idea I'd like you to think about is if I had a coin and I think that the coin is biased, how many times, let's say, actually, I think the coin is biased towards heads, so let's be explicit about that. How many heads would I have to get if I throw the coin 10 times for you to agree that it would be biased? So if I threw 6 heads, would you think it was biased? What if I threw 8 heads? What if every single time I threw the coin it was heads? How many times would it take you to think it was biased? So in order to do that, we do basically a statistical test which we call a hypothesis test. Within a hypothesis test there are many key features which I'm just going to talk about now. So if we think about our example for the coin, the first thing that we would like to think about is something called the null hypothesis. This would be our devil's advocate. So if I think the coin is biased, the null hypothesis would just simply state what we would originally think about the coin. So it would be set up as a H0, and for our coin example, we would say that the probability of getting a heads would be equal to 0.5 because that would be what we would expect whenever we toss a coin and get a heads, given it wasn't biased. The other hypothesis we look at is something called the alternate hypothesis. So this is actually what I'm trying to test. We denote this with H subscript 1, so H1, and for this one, if I want to test if a coin is biased towards heads, we would simply state that this is a probability of greater than 0.5, which means that I would expect it to be greater than 0.5 on all of those occasions. The next thing we have to think about is what type of test are we doing? There is, in principle, 2 main tests. One of them is a one-tailed test, which would be looking at our scenario here. This would be a one-tailed test because I am assuming that the probability is 0.5 and that I am testing to see whether it is greater than 0.5. If I say, for example, that I don't know if the coin is biased, but I think it is in some way, that would mean I don't know whether it is biased towards heads or towards tails. So for this example, this would be a 2-tailed test, and I wouldn't know which way it would be biased, so with a 2-tailed test, I would say that the probability of getting heads, I don't know which way it would be, but I would just know it would not be equal to 0.5. So typically, a one-tailed test is either greater than or less than, and sometimes it can be greater than or equal to or less than or equal to. Whereas a 2-tailed test, we would denote by this sign of a not equals to. Another thing we have to think about is this idea of a significance level, and a significance level is just a percentage, which would be at what percent would this be unreasonable. So if I had a significance level of 5%, I would be testing whether or not flipping a coin 10 times and the chance of me getting the amount of heads that it was, if that was less than 5%, then it would be significance, and I would have enough evidence to reject the null hypothesis. We will talk about this a bit more in the upcoming video. However, what I'd just like you to do now is, given the information I've laid out on the first slide, and you can go back and pause it here if you're not sure, I would like you to have a go at these questions on this slide, please, and I'd like you to pause it and just have a quick go. Okay, so for these questions then, as this is a greater than 0.8, this would be a one-tailed. This one is a not equal to, so this would be a 2-tailed, as I don't know which way to test. And finally, this would be a one-tailed, because I know which way to test. Stating the null and alternate hypothesis, so I know for each one I'm going to have a H0 and a H1, and I'm just simply thinking about the probability. So on average, a driving test, 40% of people pass. So the probability of a pass, I would assume, is equal to 40%. I think it is more than that, so therefore my alternate would be greater than 40%. Again, you would be welcome to writing these as a decimal, so 0.4, and you could write that as 0.4 as well. Either way, it doesn't matter, as long as you have this greater than sign and an equal sign. A medical trial is conducted to see whether the success rate of patients is 25% or not. So my H0 for here would be a percentage of a success, so probability of success would be equal to 0.25. And if I want to know whether it is equal to it or not, I don't know whether it would be greater than or less than, so it would be not equal to 0.25. And finally, the school reports that on average 20% of Year 10 students arrive late to lesson. I think it is less than that. So again, our H0, I would have to assume that the probability of a student arriving late would be equal to 0.2 or 20%. And my alternate hypothesis would be that the probability that a student is late would be less than 0.2 or less than 20%. Thank you again for watching another video. Any feedback on these would be great, and if you have any suggestions on how it could be improved or if there was anything you were struggling with, please let me know, and thank you very much.